Okay, we're back. We're live. We're ThinkTech Talks. I would call this the Good Earth series. We're into good earth these days, and we want to talk about plants, and we want to talk about the science around diversified agriculture. So we're going to call this the new tech comes to agriculture, which happens to be the same name as the program that we're doing, at Fuller Hall in the YWCA, a luncheon panel program on April 23rd. So our guest for this discussion, God, I can't read my own handwriting.
Ania, yes.
Ania Wieczorek.
Yeah, good Polish name, yes.
Okay, it's a wonderful name. She is, I wrote it down, wait, this is worth going to my notes for. She is assistant professor, still?
I'm associate professor now.
Okay,
Yes.
okay, full professor now.
No, associate
Professor, oh, I see it. Department of Tropical Plant and Soil Sciences in the College of Tropical Agriculture and Human Resources, and we're going to call that CTAHR from now on in this program,
yes.
at the University of Hawaii, Manoa. And sitting to her right is Richard Manshardt, and he is a tropical fruit breeder and a professor also at CTAHR.
That's it, exactly.
Did I get it right?
You got it right on.
Okay, so now we have our crucible to work within, okay?
Very good.
All right, so first I wanted to explain to people what CTAHR is. And I'll just give background. It was the original UH, right? It was the first college in UH, 1910.
It's the land grant.
Land grant college, very important.
Right.
And at the time,
I think it was 1907.
1907, thank you. I don't want to make it younger than it is. We give it full historical credit.
Yeah.
Yeah.
And actually, that CTAHR makes UH a land grant university.
Right.
It's because of our land grant mission. So.
Yes. You getting good sound, Ian? Yeah? Just want to be sure that your mic is in the right place. Maybe you should move it up a little higher.
I don't have another place to put it.
Yeah, and put it on the sweater.
Okay.
Okay, we're good. Okay. So, and then it was conjoined with human resources because at the time, agriculture and human resources were conjoined functionalities in the state of Hawaii. Is that why?
Shall I handle that?
Yeah,
I guess,
go ahead.
my understanding is that human resources is kind of another term that unfortunately overlaps with a lot of other people's expectations of employment, but it's really the home economics side
Right.
of, and
So
so textiles, cooking, what else? do we have
Fashion.
there? Fashion, yeah.
So why would you
So-
put one with the other? I always ask this question.
Well, because home economics was taught as part of the extension function of agriculture back in the original land grant schools, so
Okay.
it comes along.
So it keeps its historical
Right.
character that way.
Because extension is a really big part of land grant university.
Extension.
And
Tell the people what extension is. They may not know.
Extension is basically a faculty who is working with public, and our job is to educate public about specific topics that our college works on. So we have researchers who do the research, and then we have extension agents and extension specialists who would pass that research to our clients. So, for example, farmers.
All over the state.
Yeah,
I mean,
all
this
over
is
the state,
this is a phenomenon that you see all over the country, right?
Mm-hmm.
Extension agents.
Yeah, absolutely. And the third leg of the stool is education, instruction, so that we're all teachers as well as scientists, and some of us also have a,
This is a big burden.
three-way extension.
Because you
Well, it's-
research.
It's part of the job.
I wouldn't call it burden.
You like this
Yeah,
part.
I like
You
it.
like the
Actually,
extension and education
Yeah,
part.
my job at university, about 50% of that is extension. I love it. I love going out to people and talking about wonderful things that we do.
So, example, you would go to, say, for example, to the Big Island.
Yeah.
You'd make a meeting with some farmers.
Yeah.
You'd show the farmers, the best practices. You'd teach the farmers about some of the latest things that have come up in the science. You'd make them better farmers.
Yeah, we try to help them solve the problems, because farmers, as you know, have lots of different issues. They have to deal with pests, they have to deal with diseases, and they try to use all the tools that are available for them. And our job is to provide them with these tools, or educate them about these tools.
You're in a very important spot these days.
Yeah.
Because, issues of sustainability and self-reliance are swirling around us with the lack of plantations and the fact that we haven't got a diversified economy. And I think you'll be busy in the years to come. They will come and find you. They will come and demand knowledge. The entrepreneurs will be beating a path to your door. You know?
Well, the growers, I think, perpetually are looking for answers because there's always something new that no one's seen before, or there are old problems that people aren't familiar with. So there's always a client, a grower, a home gardener, somebody who needs information, and that's good. We're the bridge, more or less, between. Now, when I say we, I'm talking about other people because I don't have an extension capacity. I'm 100% research
just
and
an ordinary
and
breeder
teaching.
person.
Yeah,
Professor breeder.
just a plant breeder, right?
Well, you know, it seems to me, I mean, going back to that point, is that we had a very robust, you know, plantation system with sugar and pineapple. And we had the Sugar Planters Association, and they developed the Hawaii Agricultural Research Center, which is now somewhere out
In Kunia, I think.
in Kunia.
Right.
And we had a lot of research going. We had really wonderful industry here. We did the best sugar and pineapple in the world. Was that an overstatement?
No, I don't
No.
think so.
We really knew what we were
think so.
doing.
Yep.
So it was a loss that we don't have that anymore, and it's just too bad. So the question is, what comes out of it again? You guys are sort of the bridge that takes us to diversified agriculture. With your expertise, we will have.
Well, it's the growers too. Growers are instrumental in bringing new things in. The university has a role to try to figure out what would be economical,
Right.
what would be profitable for growers to introduce. But growers have a big part in being entrepreneurs too these days. Yeah.
And I think that our job is to really provide growers with the tools to make them successful, because Hawaii is a beautiful place to live, but also all the pests love coming to Hawaii as well. We have a perfect climate for surfing, but we also have a perfect climate for different pests to come stay. And like when you have a disease or pest that arrive on the mainland, these pests would get totally killed during the winter, but doesn't happen here in Hawaii. So the farmers are extremely challenged by these diseases and pests here in Hawaii.
Some of the pests are invasive pests.
Oh yes, of course.
From far away. Yeah.
Yeah. So our job is really to
Thanks.
try to help to find the solutions for these problems that farmers are facing.
So I put myself in your class, and I come to you and I say, look, I have a secret plan. My secret plan is when I'm finished, when I have my degree, and I'm talking about my undergraduate degree. Okay? I know you guys do a lot of graduate teaching and all that, but my undergraduate degree, I want to go out to the Big Island. I want to get somebody to give me a lease of agricultural land. I want to start a farm like Richard Ha, if you know him.
Yes,
over there.
yes.
Yeah.
I want to compete with Richard Ha. I want to show him a few things or two from the younger generation. Okay, is that scenario happening? Do we have bright-eyed, energized millennials who are looking to do that now?
Well, there are lots of people who are interested in agriculture. We have some really good undergraduates and really good graduate students who want to be involved in Hawaii agriculture. It's a tough, really tough situation, especially if you're competing against Richard Ha.
Right.
I mean, that's making it a little extreme because for one thing, he has connections. He's been here for years and years, and he knows the ins and outs. But he also has a very original, I think, and positive outlook on lots of things, not just agriculture, but he's a good example for all of us, I think.
He's a farmer who looks over the horizon. He's planning ahead. He's thinking globally, all that.
Right, he's quite a unique individual. But I think in terms of trying to make a single individual foothold in agriculture or a single family, it's a fairly rugged thing.
Oh, that's really an important point.
Land costs are expensive. Water isn't always available. We have lots of pests and diseases. But we have a cadre of people who are skilled, who
They
are
can't hear you
knowledgeable.
until you put it back up there.
Yeah, we have a cadre of people who are skilled and knowledgeable in agriculture and also just in terms of experience, both in the university at the more technical level, but people in the counties where agriculture is happening. And I think more and more all of our knowledge has to be kind of a community knowledge where we have terrific tools. I mean, we talk on cell phones to each other all the time. We have the internet. We have the knowledge to share. And I think more and more we're trying to get connections.
And entrepreneurs.
Yeah.
We want those kids to take a risk. To be, you know, I mean, their parents ran away from the plantations, or their grandparents. And now somebody is saying, you want to do this business, you know, here's what you got to do, and you're going to get your hands dirty. And you know, so it's that generation I'm talking about. So, so query then. Okay, it's not mom and pop. It's nothing out of the American frontier in 1860. We're not talking about that. That's not a workable model. But maybe there's a business model where they combine resources with others. They form an American corporation or a Hawaii corporation. They get investors. They buy equipment, serious equipment. They do research. They have an accountant and an insurance man. They have you. I mean, is this the model? If I was going to graduate from CTAHR, and I wanted to do that, I was ready to roll up my sleeves and make $1 million billion. And I believe that Hawaii can be diversified agriculture. I want to be a big player. I guess I got to make a big company. I mean, it's not mom and pop.
I think that what you have to also remember that the land is a big issue in Hawaii. Land is expensive, right? So if you are someone who's graduating from college, you have to find the money to be able to buy the land. There are possibilities for leasing, but if you, for example, are interested in growing the fruit trees, which take a long time to produce
It's a lot of capital.
The capital. Yeah. So this is a big problem for young people who are graduating and wanting to start in the agriculture. The other big problem is water, right? We all know about it, the access to water. And then again, you know, I keep going back to this, but the pests and diseases here in Hawaii it's a huge problem. And this is a really, really difficult part of farming is dealing with these diseases and pests.
I think
You're listing all these things. I'm getting discouraged
No,
already.
No, I'm sorry. I'm being realistic.
These are realities.
These are realities. How to solve all these problems.
Yeah,
right?
We have to be realistic.
This is the
right?
natural world, and it's nature's not all mother out there. There's a lot of brutality too. But I think people coming out of our college with an undergraduate degree, largely, my experience has been that they really enjoy plants. They like the biology, they like handling plants, they like doing things with plants. So they're basically horticulturalists. They're not necessarily business people. And you really need both sets of skills to make it economically.
So should I spend some time at Scheidler?
Well, we have a track of education that includes a business experience. But I think, like many things, it's probably better done sometimes by small groups of people who can share experiences, who can share skills and different interests sometimes. Some of the most successful agriculturalists are really probably more business people than they are horticulturalists. I think
so you have to make the list of challenges and meet each one, get the resources, do the reading, organize yourself, and be a businessman.
And there are different scales that satisfy. Some people are happy with a single, being a single production unit. They don't get wealthy, but they have a nice life. Other people want the security of a big income, and they would have a hard time doing that, I think, without a lot of capital to invest and a lot of forces to manage and help out. So scales can be really different.
And I think what makes it, what we as a college can do to help these people is that we have programs that try to help them deal with these problems, whatever the problem is. We have a whole entomology department, we have plant breeding, which plant breeding is very important. We have sustainable agriculture programs, organic.
We have an entrepreneurial incubator
Exactly, and we have
too,
incubator program that helps farmers to start their business or whoever else is interested. And we have also people who are interested in biotechnology, which is one of many tools that is available to farmers.
Yeah, that's the new element, isn't it? A farm now can and should address and know something about biotechnology now.
I think it gives leverage. It gives a new set of tools.
You improve your odds.
Yeah.
Yeah, I tell people that when you're building the house, you need more than just one tool. You need the toolbox. You know, you cannot build a house with a hammer only. And I think that's what agriculture is about these days, is to having the big toolbox of tools that are available for you, and then you can use and choose as you wish and what's needed.
Okay.
And that's what we're trying to do in CTAHR, is to provide these tools.
Okay, we're going to talk about the tools now right after this break. That's Ania Wieczorek.
That's good enough.
Okay, I'll get it. And Richard Manshardt, both of CTAHR, and both teaching and raising old boats as far as agriculture and the future of diversified agriculture is concerned. We're calling this the Good Earth series. We're talking about the new tech that's coming, or maybe it's already here in Hawaii agriculture. We'll be right back. Aloha, I'm Jay Fidel. This is ThinkTech Hawaii, broadcasting live from the Pioneer Plaza in downtown Honolulu. We raise public awareness about tech, energy, and globalism in Hawaii. Technology is critical to our state. A vibrant tech sector will give us new prospects in the global marketplace and will offer great careers and make our economy more resilient. Streaming live on Ustream and Spreaker, ThinkTech allows its hosts and guests invaluable opportunities to report important events and discuss important questions, and to be heard here in Hawaii and around the world. You can find links to our live streams on thinktechhawaii.com or on our mobile website, m.thinktechhawaii.com. And you can see our archive on YouTube. It's all just a click away. We want to do whatever we can to keep Hawaii relevant, connected, and thriving in the complexity of the 21st century. We hope you will help us in those efforts. Tune in today. This is ThinkTech. I'm Jay Fidel. Mahalo. Ania Wieczorek and Richard Manshardt from CTAHR at Manoa, 1907.
Yes, CTAHR, not us.
Not we look really good, you know.
Well, you know,
well preserved.
if you lead a really good life, and it's a natural life, it's a green life, you know, you live a long time.
Yeah.
Lucky we live Hawaii, right?
Anyway, we're talking about the good earth today and the technology that is coming or has come to agriculture. And I guess I want to go through the toolbox. So let's talk about biotechnology first. What's the latest and greatest? I mean, when they come into your classes or in the extension program, what do you tell them about biotech? What role does it play in the operation of the farm?
Well, I tell my students that biotechnology is one of many tools. You know, you cannot rely on one single tool to be successful. And I tell them that biotechnology can help solve some problems. It's not going to solve everything. It's not going to be silver bullet that is going to help agriculture, but it's one of many tools.
Give us an example of a problem that is solved by biotechnology.
Well, I think that one of the great examples here in Hawaii is rainbow papaya. And papaya got sick here in Hawaii a good couple years ago with a ring spot virus. And actually Richard was one of the team members who was involved in developing.
With Dennis Gonzalez.
Yeah, and
Dennis and Maureen Fitch and Jerry Slydom.
That was a real achievement. I mean, that was a notable achievement in Hawaiian agriculture, I think.
It definitely was. And I mean, I'm not blowing my own horn. I had a relatively small role in this, but the fact that it got commercialized is really what's unusual, I think. There are other projects that involve biotechnology, but they never really made it to commercialization.
When you say commercialized, you mean there's a plant patent out there or something? And
no.
that can actually yield some...
There is a plant patent on these particular varieties, but what I mean by commercialization is that this is a highly regulated development process. As scientists, we put together the needed pieces, but there's a whole series of tests to make sure that things are safe to go into the field, that they're nutritious, that they haven't been changed in any way by the process of genetic engineering, and that they actually do the job that they're designed to do, in this case to be resistant to viruses. So this is a multi-year process of testing before it can be released as a variety. Sure. I guess I really want to emphasize that because I think many people think that people go into the lab, scientists wear coats and crank something out over the weekend, and the next thing they know, it's on the table.
Eureka!
Yeah, it doesn't happen that way. This was a 10-year process of getting these plants through the regulatory agencies and out.
So Sorry,
What I
Ania.
thought that was really interesting about papaya is because when papaya got sick and got ring spot virus, was no other solution. So sometimes, you're looking for solutions and you can find them or not, but in case in papaya, if not for this technology, we would have actually lost commercial production of papaya. You maybe will be able to grow 1 or 2 trees here and there.
But not at commercial scale,
commercially,
and that would have killed the industry.
Yeah, that would kill the industry. And the problem was that there was no way to control that virus another way. And that's where this tool is really fantastic, because what it basically does, it introduces the trait into, in this case, into papaya, and this trait is very novel for this specific crop, and is giving papaya ability to survive in the area where you have a virus.
It's a biotech miracle,
Yeah.
really.
Yeah, and
short of that, it wouldn't have
you would
papaya.
not have a papaya in Hawaii. And also another thing that was fantastic about papaya is that this is only crop that was developed and commercialized by the public institutions. So there are other genetically engineered crops that are on the market, like corn and soya beans and cotton, and everybody talks about it, but these ones are usually developed, or they are developed by the big corporations and big industry. But papaya was really developed for local farmers. It was a project that was really done to help Hawaii farmers specifically.
Yeah, that's what makes the whole experience so sweet.
And I think
The
this
specifically
is,
Hawaii solution.
Yeah,
So
Dennis
that's-
Gonzalez was born in the Big Island. Maureen Fitch was born here. I guess I'm the only component that's the
Maybe you held it all together.
holiday element. Yeah. I'd like to just add a bit to that, if I could, just to
Sure.
talk about what we mean really by biotechnology and
Please.
how different that is. As Ania says, basically, with the papaya, we were able to find a particular trait and move it without making a cross, move it into the DNA of the papaya, so it becomes a papaya gene, and that confers resistance. Typically, when we do fruit or crop breeding, we make cross-pollinations between parents that have the traits we want, and then look in the progeny,
That's the
the
Mendelian
seedlings.
technique.
Yeah, exactly. And for many things, that's the best way to go. It's simple. It's not regulated. It's fairly cheap. It's not, I would say, easy necessarily. It takes time, and there's some traits.
Classical breeding.
Classical
Yeah.
breeding,
Mhm.
yeah. But no one's going to be replacing that with biotechnology. These are kind of complementary sorts of skills. And just to make that point, it's hard to do that kind of classical breeding with tree crops that have such long generation times. If you're breeding mangoes and you need to have 6 generations to get to something, you're not going to do it.
But I
So
hear
you
you
can
saying,
take a
though-
trait and add it,
But
through
I
the
hear you
genetic
saying, though, is that if we were very patient and we wrote it all down carefully and we had really good memories and our children's children had good memories, we could do the same thing. We could save the crop.
Well, not in case of papaya, right? Because in the case of papaya, it was no natural resistance. So this natural resistance has to exist somewhere in the genome of papaya.
So the ring spot virus was from outside.
I don't know
I
where
mean,
it
is
is.
it
The
indigenous?
gene for resistance. Yeah, well, yes.
Yes,
it
I-
probably-
Otherwise, they would have had resistance, right? It came
Yeah.
from somewhere
Yes.
else and attacked a vulnerable plant, essentially.
So you could
Right.
breed all your life for resistance, but you would never be successful because, and they tried it. The scientists who were involved in this project actually tried for years to breed in that resistance, but that recipe basically didn't exist in the genome. I tell people like genetic engineering is like I like to compare it to the cookbook. So like DNA is like a recipe for life. That's right. Yes.
Can you get this, Marshall?
Chef Anya.
Chef Ania, here we go. But the DNA it's like a recipe for life, and if you want to cook, you need the cookbook. So in English language we have like 26 letters, and these letters make sentences, and sentences make words, and then eventually we have recipes. And I tell people that, and then you end up with the chapters, like let's say recipe for pie or Polish pie. And if you have a cookbook and you don't have a recipe in your cookbook for Polish pie, is no way that you can make it, right? So genetic engineering basically allows you to take that recipe from the Polish cookbook and put it in your cookbook, and then now you can make the Polish pie.
What I get out of this is that there are some cases, and papaya is a good example, where you really don't have a choice.
Exactly.
Just the way things set up, the kind of plant, the kind of attack on the plant, the timing and all that. You must use every recipe you can find,
Exactly, yeah.
or you will lose it. There'll be nothing left.
Yeah, the virus resistance gene actually comes from the virus. So it's, it's very different from what you would find in papaya.
We have a few minutes left before the next break. Can you explain that? So you go into the virus at the, DNA level?
Right. This is what Dennis Gonzalez's contribution was, that he isolated this particular gene. The whole concept was built on the idea that there's a very close relationship between a pathogen and its host, and if you get the pathogen expressing something at a wrong time, the host won't recognize it, and it's not able to regenerate itself within the host plant. So by taking that gene from the virus, engineering it so it would be recognized by the plant makes part of the virus in itself. And it's sort of analogous to an immunization, where when the virus attacks later, the plant recognizes it and doesn't allow it to
It's sort of an immune system thing?
It's analogous to that, yeah. Plants don't have immune systems. What actually happens is that when the gene is expressed in the plant, the one that's put in there intentionally, the plant has ways of turning off that gene. So when the virus attacks, it needs that gene in its own genome to complete its replication, its reproduction. But the plant turns it off.
So it can't.
Right, so it can't replicate.
This is really amazing. It suggests two things to me. One is that it's not only the papaya. You could take another virus and another plant and a whole new situation. And from what you guys learned in dealing with the ring spot virus, you could address another virus.
Absolutely.
And it also suggests to me that some of the logic in what you just described could apply to human antigens. No?
This whole mechanism by which the virus gene is turned off is one that's being utilized in lots of other areas.
There must be research that follows what happened with the papaya.
In fact, it
other
was
areas.
sort of discovered through this process of moving foreign genes into new locations and finding out what the consequences of that were, one of which is that gene is silenced, it's turned off. And that technology is now being utilized, I think, in cancer research and things like that, in medical areas.
Right here in Hawaii. What a contribution. Right. So let's take a break.
All right.
That was a bit to swallow.
Yes.
And we'll come back and we'll talk some more about the good earth and the new technology coming to agriculture in Hawaii with Ania Wieczorek, excuse me, and Richard Manshardt, both of CTAHR, the College of Tropical Agriculture and Human Resources at UH Manoa. We'll be right back after this break.
All right.
Hi, my name is Dr. Rafi. Every week, I'm right here at ThinkTech Hawaii, 3 p.m. on Mondays. My show is Boris' Bio Briefings. What do we do here? Well, we watch sperm swim, we see if they catch anybody, we check out the latest biosimilars, you know, the kind that, what was his name, the guy with the bicycle? I guess we forgot his name, but he was taking EPO and other human growth factors. We'll be talking about human growth factors. You want to know where to get some? Maybe I'll tell. Anyway, you can catch me, as I said, every week right here, Monday, 3 p.m., ThinkTech Hawaii, Dr. Rafi. You can also find me on Twitter, BioInfoMedical. Or you can catch me on Facebook, Dr. Rafael Boritzer. I'll be happy to converse with you. Aloha.
Okay, we're back. We're live. We're ThinkTech Talks in the Good Earth series here. On a given Thursday, we're talking about the new tech in agriculture with Ania Wieczorek and Richard Manshardt, both of the College of Tropical Agriculture and Human Resources, which we would like to have more on the show, actually, because we think it's an important part of
We will be
diversification.
back.
Great.
And diversification's our middle name.
Yeah, we have lots of interesting people up there.
Okay.
So we'll come back with the reinforcements.
I want to talk about, and in the same regard, I want to talk about this. I pulled this off the web, you know, it is very suggestive, but what is it? This is a flyer about what you're doing in biotech and plant breeding.
This is actually a bulletin that I'm publishing twice every month. So it comes out on the 1st and 15th of each month. And I just started it. We have a list survey that we send it to. And also we have it on the website. So you can have a current and the past issue, you can read it. And we're basically talking about biotechnology, and that's why it's called Biotech in Focus. It's written in the lay terms, so the normal human being can understand. And it's basically short topics that we're discussing each time that are related to biotechnology. And this year specifically, I'm going to concentrate about genetic engineering, because genetic engineering is such an important, but also the same hot topic that lots of people try to find out more information about it. And
So how can I get in on this?
Yes, so you can even send me email at Ania, ANIA, @hawaii.edu, and you can ask to be put on the list. Or you can go to the website, and we have an address for it, which is ctar.hawaii.edu/biotech in focus. And
Okay. CTAHR is CTAHR.
yes.
Yeah.
But
Okay.
the easiest way is just email me, and then I can put you on my list, and every 2 weeks you will get email from me with a new current issue.
Okay, before the show, you were also talking about an open house that you do at CTAHR. You have people come, and the kids come, lots of kids.
It's not an open house as such. It's what I try to do. I mean, big part of my job at CTAHR is to educate people about importance of not even specific biotechnology, but about genetic in agriculture. So I have a program for school the children called Genius Day. And we have been running that for 5 or 6 years now. And we teach kids about importance of genetic in our life, and also importance of genetic in agriculture. We don't talk about biotechnology because these specific kids are too young. We mostly work in this case with the 4th, 5th, and 6th graders. And this year alone, we were able to bring almost 1,600 children with schools to our program. We also have a Saturday program that brings the families on campus, and we have what we call it missions. And
But people who might want to enter the school,
what's that?
for students
It's
who might
for-
want to
it's-
enter the school for.
No,
program.
this is actually, it's a program. It's
Yeah.
like a Saturday program for families
Okay.
and kids. And right now we are taking kids from the 1st grade to 6th grade. And then next year we're also opening 7th and 8th grade. And it's just a fun way to introduce kids to
that's
science. It's all hands-on. Kids come and do the experiments and do the...
You
Then
would
they go
believe
build a science fair.
Anya's
It's like a
lab,
science,
Anya's
yeah.
lab, and all of her students pitch in with this. It's a huge.
So it's a huge
Yeah.
teamwork. I have almost 14 people who are involved with it at one point or
I
another.
don't know,
So
1,600 kids is a lot of kids.
Right. Not all at once.
not at once, so we bring like
Okay.
100
Thank
kids,
you for that.
100 kids at once, and so on. But yeah, kids get a chance to take the DNA out of papaya and look at the DNA. They get a
Oh.
chance to look at the cells under microscope and learn the difference between the animal and
They
plant
get to wear
cells.
lab coats.
And
too.
they'll get to wear the lab coats. Yeah.
Purple gloves.
Yeah. So kids really like it, and the purpose is just to show them that science can be fun.
With amazing,
Yes,
miraculous
amazing,
results,
yeah.
too.
Yeah, because right now we have quite a big problem in United States and in Hawaii with the science education. Overall, United States students are not doing that well in sciences, and when you rank us with the rest of the world, we come below average. It was a study in 2010, I think, that looked at 2012, and it basically ranked United States children 36 out of 65 countries. So we're not doing
We're
really
sliding
well in
down the
science.
slope, yeah.
And the situation in Hawaii is even worse. Our 8th graders are 41 other states that do better in standardized testing in sciences. That Hawaii student. So I think that science is so important with all these new technologies that are coming out and all these new jobs that are going to be coming out with this new technology. We really have to educate our students about science and show them that science can be fun, right? Because quite often students are afraid of science. They think that science is so difficult and so foreign. But by showing them how fantastic it can be, we're hoping to get more kids interested in science.
Yeah, I'm just now, in fact, today I submitted a movie on the to OC16 on the science fair, and you know, one of the there's two interesting parts of my own reaction to that. Number one is there are kids on every island who are wild about science, and good at it, and they're like they're in an altered state when they start talking about their projects. They go so fast, you get so excited. It's really amazing to watch. I'm sure you see that all the time.
Oh my, they just see that excitement.
Not
in
all the
their
time.
face,
It's still a
yeah,
good.
but we don't have enough of these
special
kids. That's a problem.
Exactly. That was my second conclusion, that this is a fraction, and that the others, you know, may think this is all for the brains. You know, we'd rather do other things, and you know, we don't care. And somehow we have to reach them all, because in the 21st century, it's all about science.
Yeah, and that's our future jobs. You know, 10, 15, 20 years from now, you have to know. I think you're going to need to know science to be able to get a good jobs, because technology is moving forward.
Let me take a digression and ask you, will those jobs be here? I mean, I am remembering Ed Cadman, who was the dean of the medical school back 15 years, well, almost 15 years ago. And his dream was to have a big pharma biotech research campus in Kaka'ako-Makai. That was his dream. He had charts and graphs and all that. It never happened, you know. The medical school, then the research building, which I hope they're using more of it now than they were then. But you know, can we ever achieve that, do you think? To be a biotech center, to be, you know, a junior San Diego?
Well, I think, I mean, I'm not an expert in entrepreneurship, but I think ideas are critical. You have to have creative people, whether it's finding a niche for production in agriculture or a new idea that's marketable. And information, I'm not telling you anything, Jay, I know you know this, but information is highly portable. It's not a commodity that you have to ship in a boat or a plane. So ideas, as long as they arise locally and can be capitalized on, I think you know, there's opportunity. But you need background, you need support.
The whole community has to come up, right? I mean, you guys are the leaders, but you need every school, every child, every parent, every legislator, for example, to get behind this.
Yeah, and I think programs like the one that Ania's been describing, where she deals with children in a positive environment, with excitement, with you know, students who are demonstrating that they're involved in this, is really powerful. It's a way that kids get turned on. They get involved actively and not just passively soaking up knowledge, but they're doing something with their hands.
And when they do that, you know their lives are changing.
Yeah.
You know they're locking onto something, and it's going to define, you know, the way forward for them.
Yeah.
Well, I wanted to visit with you on the issue of the kalo. I don't know if that work was done in CTAHR. It might have been. This is back when, and during the McLean years at the university, a demand was made by people who objected to a plant patent on the kalo, and they said, you can't do that. You can't have a plant patent on the kalo. And the university, in my recollection, offered it to the culture groups, activists who were objecting to, because kalo is a special cultural plant. And those groups who were demanding that the university stop operating under the patent, they said, no, you don't get it. We don't want the patent. University offered it to them. We don't want the patent. We want it to go into the public domain, so that, you know, there is no protection on the work that was done. And that's where it went. It went into the public domain. The end of the story is that it's, why do research on something where you can never have the prospect of having a plant patent.
Yeah.
That's really
I think
altruistic.
I think that with Carlo we have to be careful because Carlo has a really special meaning to Hawaiian community, and we have to remember that when we live in Hawaii, we are here living in this culture, that Hawaiian culture, and I think that we have to be respectful. So me personally, I think that, you know, we should respect the wishes of the beliefs of Hawaiian community on that. And not everybody agrees with me, but I think that we have to kind of, when we're talking about technology, to be successful for biotechnology or any technology to be successful in Hawaii, we have to take the cultural beliefs under consideration. Otherwise, we're going to have the two camps of people.
You can't get there.
And we're not going to be able to get there. So I think that in this case of Carlo, it is a special case, and maybe, you know, putting the patents back into the public domain was a good thing to do. You know, that's just my personal opinion.
Well, you know, this is all somehow related to the GMO issue, you know,
Yes,
controversy.
yeah.
And I mean, I'm happy that the papaya was somehow accepted from the ordinance in the Big Island. But I'm sad to see that ordinance actually has had a negative effect on a lot of farmers in the Big Island, because it's not so much Monsanto or Pioneer that's affected. It's every farmer is affected.
Yeah, that's right.
And they got to file papers, and they got to make disclosures. I don't know what. There's a million little bureaucratic things they got to do now, intended to discourage them from using GMOs. And this is not a good thing for diversified agriculture.
And it's not good for businesses, right?
Yeah.
That if we really want Hawaii to be significant in the technology and be a mini San Diego, as you mentioned, we have to be more open-minded to different industries. But you know, the topic of genetic engineering is so controversial because there are so many different things that are involved in this discussion. You have a science part of it, you have safety part of it, but there are lots of different social issues as well that get thrown into this bucket of discussion.
Is it everywhere or just here?
It's everywhere. This is a really international debate going on, and some of these social issues are when, like, if you're opposing big corporations and you're opposing this, you are by default going to oppose genetic engineering. People don't distinguish between the technology and, let's say, big corporations and so on, and they don't realize that actually what makes United States what we are is ability to have a businesses and be successful and so on. But there are lots of social issues like labeling. You know, the labeling of genetic engineered crops. This is, in my opinion, pure social issue, and it has to be discussed on before we decided to label or not to label something.
Yeah. Well, I wonder where it fits. You know, in the diversified agriculture opportunity, because. It seems to me, you guys must think about this a lot, that as we go forward in a more complexified world, there'll be more challenges, more pesticides, insecticides, who knows what, that will undermine the classical farming techniques. And we need to build crops that will survive and feed the world, or at least feed the state.
At least United States or Hawaii.
Make it safe, And you know, increasingly, I mean, tell me if I'm wrong about this, but it seems to me that increasingly we're going to need to do biotech and we're going to need to do genetic modification to build crops that will feed the world and our state, which means that we have to get over a resistance on this if we're going to have the industry. It seems to me the industry is one of the best things we can ever do here. So therefore, we have to get into the technology.
Well, it's, you know, everybody carries a lot of baggage, historical, which is good. We don't want to lose our roots, but we have to be pragmatic and
it's an
realize.
advised term, roots.
Roots is a good thing. Roots is a good thing. That's okay. I mean, we all come from someplace. We all want to honor that.
Every plant and every human being has roots.
Well, it's you know, a good horticultural term, right? But
you can see his plant
but the
breeder.
reality, you know, is that the world today isn't the world of 100 years ago, and techniques that were suitable and appropriate back then are no longer suitable. They might, or I should say, they're no longer appropriate. They might be possible, but they're not efficient, and if we are, as a human population, which now, what, over 7 billion, I guess,
Yeah.
it requires highly efficient agriculture to make enough food to keep everybody going. And I don't see a way that that is, not going to be true. So if you accept that fact, then we need all the tools we can get to
Your
move,
toolbox metaphor, yeah.
move modern agriculture ahead so that it can continue to be a success story and not a disaster, which is also possible.
I think that it's very important for us to remember that the world has really changed. And I love that example. If you go back 150 years, which is not really that long, in 1850, we have 22 million people in the United States. And 74% of these people were physically involved in farming. Now let's go back to 2012. We have 313 million people, a little bit more than that.
More than 10 times.
Yeah. And only 1.5% of population is farming. So what has happened is we have increased our mouth to feed, our population, but the people who are farming are there less and less of them. And it's one more thing that has changed over the last 100 or so years is the fact that, in 1850, you ate what was available to you locally and what was in season. Now we want to eat everything all the time.
Yeah.
So because of these two things, agriculture had to have changed, to be able to produce food for 330 million people and to be able to eat what we want anytime. The agriculture had to change, and it did. There are lots of different. We only talk about one or two different tools, but there are so many different tools in agriculture that we have been using for over 150 years, like classical breeding, mutation breeding, tissue culture, and so on, and then finally genetic engineering. So I tell people that genetic engineering is just, it's almost like traveling by the horse and traveling on the plane, right? It's we move forward. Having transportation going from point A to B. The way that we travel has changed, and it's the same with biotechnology.
Speed and efficiency.
It's
really
just the next step in the evolution of how agriculture is changing.
All things being equal, population will increase.
Yeah.
Food production will be under increasing pressure. Climate change will redistribute the availability of water. That will make it more complex. And I think we, the country, runs the risk of losing agriculture as we lost manufacturing to Asia, where I'm not saying their agriculture is as good, but it's fast, and it may come back with melamine all over it. but I worry, and I'd be interested in your reaction to this, I worry about the possibility that we won't keep up with our own needs, and we will continue to buy 90% of our food from somewhere else, and we will become dependent on that, just as we are dependent on oil. And so this is really a mission-critical question we're talking about,
And
for our own future.
especially for Hawaii, because we are even more isolated than the rest of the mainland. I think we really need, as a state, to be considering the vulnerability of our food chain. And we are. I mean, people are certainly talking about it. And I think that brings up the issue that none of these methods of production really are inappropriate in their own right environment. Biotech isn't the answer to everything. Organic agriculture has a perfectly good niche. And I think the objective that we have is to find out how we can make our agricultural system sustainable in the long term and still meet people's expectations in terms of the variation, variety, adequate supply, and safety. So it's a big challenge.
Well, as time goes by, I mean, I would guess you guys are becoming more important every day.
I don't know if
Because
we're more
you're
important, but we're more busy.
Well, that too. That's part of it, no?
I
I don't feel very important. But
Due to me.
Yeah, I think we're all important in this because we're all mouths, we all eat, we all need to be thinking about production and safety of production. So it's an important topic. Among many, many, many other important topics. These are all
Sure.
social issues as well as technical ones.
The
So
one thought I've had while talking to you here in the last few minutes, we spent a lot of time on energy, okay? And in energy we have these we have these goals. So by X year, we should have, you know, X percent of renewable, local, indigenous, clean energy, and we should be using that instead of foreign oil. Okay? Why don't we have goals like that in agriculture? Why don't we say that, so it's 90% imported now, you know, in 5 years, 80%, and then 70. Same thing, same concept. Could that work?
I think that there are some goals. I don't myself know if there are numbers that we're setting out, but the state is trying to become self-sustainable or more self-sustainable, and each of us can actually help by planting that little tomato in your backyard, or just growing little herbs on your balcony and
Or
things.
buying things that are produced locally.
But I think most of all, we have to support the local agriculture. So sometimes maybe it costs a little bit more, but I feel that if you buy local, and money stays here, you support the local farmers, and I think that is if you want to do anything, you know, to help this sustainability and things, then we have to buy local, and then we have to try to grow whatever we can ourselves in the backyard, right?
And we didn't even get to aquaponics
Oh, yes.
or aquaculture at all. We didn't get to hydroponics, or those indoor farms that are being, there's one indoor farm, you know, in Kaka'aka. And there's one on the roof too.
Oh.
So
As
Green
a-
roof.
as
so
a-
we have to come
You
back.
have to have a toolbox, right?
Yeah.
And all these things that you're talking about are part of that toolbox.
Yeah.
So,
It should proliferate.
Well, maybe we should talk more often. It's a good idea.
yes,
Good
I
idea,
think we
Jen.
should talk more about
Okay, well, thank you guys. I'm sorry we're out of time. Ania Wieczorek and Richard Manshardt, both of CTAHR, doing good work for the good earth.
Jay.
We're talking about the new tech in Hawaii agriculture here on ThinkTech. Thank you very much, both.
Well, thank you very
You're
much for
welcome.
inviting
Very
us.
welcome.
Aloha.